Hello students, let us see this problem. This is the 13th problem of 1 week challenge problem, right? So what this question is saying that a motorcycle, which we have to treat as a point particle, a motorcycle is traveling on a horizontal circular track of radius 28 meters starting from the rest. The coefficient of friction is constant. What is the minimum distance the motorcycle must travel in order to achieve its maximum allowable speed? So here I must clarify you that the maximum allowable speed has nothing to do with the capacity of the motorcycle, right? So the motorcycle can go any value of the speed, right? What is happening here? Let us say this particle is moving on this circular path starting from here, from rest, and it is increasing its speed as soon as fast as it can, right? Because it want to achieve the maximum allowable speed in traveling the minimum distance. So let us say the minimum distance is s minimum, and after traveling this much distance at this particular point, the particle has achieved its maximum allowable speed. So why is there any condition on maximum possible speed of this motorcycle or the particle, right? As you all know, during the circular motion, the particle must have some kind of centripetal acceleration in order to change the direction of its velocity vector. And during this motion, while it was accelerating, while its speed was changing, it must also have another kind of acceleration called tangential acceleration, which was actually increasing the speed of this particle. Where is this accelerations, these two accelerations coming from, right? It must come from some external force. On the horizontal plane, there is only one force which can provide the acceleration, these two accelerations, that is friction force. So the maximum value of friction force is limited, right? It is limited by the normal reaction. So the maximum friction force is mu n and value of n is mg. So mu mg is the maximum friction force possible. So the maximum acceleration of the particle must also be equal to mu mg by m, that is mu g. So we have a fixed acceleration which will have to divide into two parts, one tangential and one centripetal. After this maximum speed, after this maximum allowable speed, the particle will only have one kind of acceleration, that is centripetal, right? Because the maximum value of acceleration is fixed, and at that moment when the centripetal alone becomes equal to that value, we are not left with any value of the tangential acceleration. So after that point, the particle will keep on moving with the same speed, right? So during that motion, between starting from rest and uh, when it reaches to the maximum allowable speed, between this motion, let's say the particle when it was here, what is happening? It will have two kinds of acceleration: centripetal acceleration, that is omega square r, and tangential acceleration, that is r alpha. And the maximum acceleration which was possible, that was mu g. And obviously we want always that the friction is acting at its maximum. That is how we are going to get the maximum tangential and maximum centripetal. We want this process to be as fast as possible, right? We want minimum distance in order to achieve the maximum allowable speed. So acceleration is always, net acceleration is always mu g, but these two components will keep on changing, right? So just looking at this moment, if we want to say that the angle phi is between these two vectors, mu g and net acceleration and tangential acceleration r alpha, we can write r alpha equal to mu g cos alpha and omega square r, that is centripetal, equal to mu g sine phi, right? What we can do next, we can differentiate this second term with respect to time. After that, we'll be getting this equation. So just by looking at this numbers 1 and 2, you all must have gotten some idea that we'll be using these two equations to, solve the problem further. What we'll do that, if you just look carefully at the second equation, this whole term r into d omega by dt. So d omega by dt will become alpha. So this whole part r alpha we can substitute from first equation. So here we will get 2 omega mu g cos alpha, and on the right hand side we are also getting mu g cos phi, sorry, cos phi, this is cos phi. So we can cancel this whole term mu g cos phi, and we'll get 2 omega equal to d theta by dt, right? So after that we can substitute d omega as d theta by dt. 2 will get to the right hand side, 1 by 2, d phi by dt will cancel dt and we'll get d phi by dt equal to half of d phi by dt, right? So we want to actually calculate this arc length S minimum, and if we get this value delta theta or the angular displacement of the particle, we'll get this S minimum, right? So we want to get this delta phi and delta theta, and we can use this value delta phi right here. So what is delta phi? The change in the value of phi initially. What is happening initially when the particle has begun its motion? At that instant, the omega part was zero, right? So this mu g will be actually acting in the tangential direction. So initially all the acceleration is actually going to provide the change in speed, and at the final moment when the particle has achieved its maximum allowable speed, at this particular instant all the acceleration is actually providing centripetal acceleration. There is nothing left in the tangential direction, so the speed will become constant. So finally what is happening, this mu g vector will come into the direction of omega square r. So the final phi will become 90 degree or pi by 2, and initial phi is 0. So change in phi will become pi by 2 minus 0. So this will become delta theta will become pi by 4, and after that it is very simple, that arc length equal to radius times angle subtended. So upon solving we are getting 22 meter as the answer.